Hey everybody, what's up? This is the third episode of Redstone Functions, and in this episode I will tell you something about monostable circuits. Monostable circuits are used for controlling signal lengths, and they are called monostable because they only have one stable state. They have two states, and the other one is pretty much unstable, which means that by default the monostable circuit is in the stable state. When it gets an input, it switches into the unstable state. But this means that as soon as it switches into the unstable state, it will automatically switch back after a certain amount of time. And that can be used to control the signaling. Let me show this. So, you take two blocks, put one there. Repeater in the middle, set to 3 or 4 ticks. We set it to 3 for now. The torch here and the torch here. Some wire to connect this, and have your input here and your output here. So now let's take a lever, which I of course don't have in my inventory. Let's take a lever, and as soon as I flip this lever, you will see that this thing will simply blink on for, actually this is 0.2 seconds. Now, what happens? We get a signal input here. This torch turns off after 1 tick. 2 more ticks later, because this is set to 3 ticks, this will turn on. That means that this block does not have a redstone input for 2 ticks, which is 0.2 seconds, so this torch will turn on for 0.2 seconds, so the signal output is 0.2 seconds. And this is one of the versions of a monostable circuit. What do you use monostable circuits for? Obviously for controlling signal lengths, but what's that useful for? Well, for example, take a sticky piston. Take a block. If you give this thing an input, it pushes the block. If you turn off the input, it pulls the block, obviously. But if the input is short enough, actually 1 tick, 0.1 seconds, then the piston can only push or pull the block, like this. Obviously, if you want to have this automated in some kind of circuitry, you need some way of making sure that you get a signal input of 1 tick, and monostable circuits are the way to do that. Problem is, this thing is set at 3 ticks now. That means the output is set at 2 ticks. If I put this to 4 ticks, the output will obviously be 3 ticks, because the output is, in this case, always 1 tick shorter than the delay on this repeater. But the problem is, if I put this on 2 ticks now, you will see the output doesn't blink on at all. The thing is, take a look at this wire here. I'm not sure. Yeah, you can see it. Take a look at that, and you will see that it actually turns off for actually that 1 tick that it has to turn off. The problem is that the torch doesn't turn on, because with one update Mojang actually prevented torches from accepting inputs that are only 1 tick long. So the torch just doesn't turn on because the signal here is too short, like it's off too short. So the torch just ignores that. That's why we cannot create a 1 tick signal length. That's obviously bad, because with that we cannot realize this contraption. So we need some other way to do that. The design that we can use for creating a 1 tick signal length is way simpler to build and way smaller. And yeah. You simply build a sticky piston facing upside, with a block on top. Put a repeater facing away from that block, set to 1 tick. This is your output, and this is your input. Really simple. You can put your input to the side as well, of course. And now, you can see that thing turns on. You can actually adjust the signal length too by simply adjusting this repeater, and the signal output will always be the same length as the delay on the repeater. Both designs have their advantages and disadvantages. Advantages of this design are pretty obvious. First of all, you can actually create a 1-tick signal. Second of all, it's way smaller and simpler to build. Disadvantages are, first of all, it uses more resources because you need the sticky piston, which you do care about if you build that in survival, right? If you build that in creative, it's pretty much, yeah. And the second disadvantage is that the maximum signal length that you can create with this thing is 4 ticks, because that's the maximum length that you can set this repeater to. This advantages of this design are you can create signal lengths that are longer than 4 ticks, because this is 3 ticks. But you can simply extend this by building this block, like up here, with the torch of course, and just putting more repeaters in between, and giving them a longer delay. And that way you can create longer signal lengths, if you want. So that's first advantage. The second advantage is that you need less resources, which you of course again only do care about in survival. Disadvantages of course are you cannot create a 1-tick signal length, and it is more complex and more space inefficient. Well, that was kind of, yeah. So these types of monostable circuits are called signal limiters because they can only limit the signal length. They depend on the fact that the input signal is longer than the signal that you want to have an output for, right? So if we take, for example, this should be this 12 ticks, so this signal should be 11 ticks long. If I put this on, and that's pretty much it. I mean, you can't really measure this right now, but yeah, it's actually 11 ticks. But if I put this on for a shorter time, like this, you can see this only blinked on for the same time that this has been on. So that doesn't work. You cannot increase the signal length with this design because it's a signal limiter. For increasing signal lengths, there's another contraption, which is also a monostable circuit, which is called the signal lengthener. And you build that pretty much by building a RS knowledge, like this. I've explained those in the last episode of Redstone functions. And giving it one input, of course. And now, this will be the output. So what happens now is, as soon as I give this thing an input, the RS knowledge flips and that turns on and stays on, right? We don't want that. We want it to turn back off after a certain amount of time. So what we do is we connect the second input of the RS knowledge with one of the outputs. So the RS knowledge automatically resets itself. So what we do is we just put in some repeaters here, like this, and just give this a bunch of delay. Obviously you can adjust this delay by putting in more repeaters or less repeaters. And that's pretty much it. So what happens is you give it an input, the RS knowledge flips. This turns on, that's your actual output. And this thing also turns on, but the signal needs quite a long time to get through this, and quite a bunch of time later, which you can of course adjust, this signal, this RS knowledge will flip back and turn the signal output off again. So like this. Da-da-da-dum. And there we go. We have a longer signal output than a signal input. This is just the other way around than a signal limiter. It depends on the fact that the signal input is shorter than the signal output, the target signal output, because otherwise you will have both inputs of the RS knowledge activated, and that, as I explained in the last episode, can lead to all kinds of crazy behavior in the RS knowledge, so you will have quite a problem, in some cases at least. So, there are two differences with these things, like two different types of signal lengtheners and signal limiters, called rising edge and falling edge. Most redstone contraptions in general are on rising edge, but some of them are actually falling edge. What does that mean? Well, rising edge means change of the signal state from 0 to 1, so from off to on. And the falling edge is a single state from 1 to 0. So this is a rising edge monostable circuit. What happens is the thing fires as soon as the input turns on. A falling edge monostable circuit would pretty much only do something when the signal turns off, right? To create a falling edge contraption is pretty simple. You just take the rising edge contraption, which is the standard, and put a NOT gate in the front. So as soon as I give this thing an input, if I find some way to give it an input, wait a second, there we go. As soon as I put this thing off, so we have the standard input is on, and as soon as I turn this input off, the whole thing will give an output, because when I turn this thing off, that thing will be turned on, and this is still rising edge. Yeah, so that's pretty much it. I have one more single limiter for you, which is pretty much the same design as this one, but it's vertical, so it's more useful for things like computers and stuff. You build it pretty simply like this. You just build a triangle like this, and pinch out these two holes. Put your repeater here. Set to 3 ticks at least. Put some redstone here. First dodge here. First dodge. Second dodge there. Input, output. Obviously, you can just increase this like that by just doing something like this. Right. So that's about it. Thanks for watching. I hope you liked the video. If you want to see more videos of this kind, you can of course subscribe. And yeah, if you have any ideas or requests for redstone tutorials, like for my redstoning series, then you can of course post them in the comments. And yeah, that's pretty much it. So see you next time. Goodbye.